Welcome to Lesson 1. Before we start learning pseudocode and programming concepts, let's take a minute to explain how these tutorials work, what you're looking at on screen, and how to follow along when code's being demonstrated. These lessons are designed to make programming visible. Instead of lectures, I wanted to create active, real-time demonstrations. This way, you can see what the program remembers, what line's running, and what the program does as a result as it happens. Instead of trying to imagine how things are working in the background, we see each step from start to finish. Most code lessons use 3 panels. The code windows, where the pseudocode's typed. Computer memory shows values that the program's keeping track of. Program behavior shows what the program's doing, including output, decisions, and other runtime events. The code window is the main script area. It shows the instructions we want to implement and what we'd like the computer to do. In these early lessons, most examples are written in pseudocode so we can focus on logic before worrying about semicolons, braces, imports, or language-specific syntax. Computer memory is a simplified teaching view. It's not trying to show every detail of real hardware memory. It shows the important values by name, so when a variable is created or changed, you can see the value appear or update immediately. Program behavior is where we explain what the program's doing. Sometimes it shows output, sometimes it explains a decision, sometimes it tells you that a loop started, a condition was true, or an action returned a value. The information in program behavior is meant to add a little more detail and clarity to what the program's doing. A walkthrough has 2 phases. First, the code's typed onto the screen. Then the tutorial runs through the code one line at a time. During that second phase, the highlighted line, memory panel, and behavior panel work together. Highlighting and sound cues help direct the flow and help you keep up with what's going on. When a line's highlighted, that's the line we're focused on right now. It doesn't always mean every real computer operation's happening on only that one line. It means that, for learning purposes, this is the instruction you should pay attention to. Pseudocode lets us talk about programming ideas in plain, structured language. It's not meant to replace real code, it's a bridge. Once the logic makes sense, translating that same idea into Python, JavaScript, C#, Java, or another language becomes much easier. The pseudocode reference for this series is available on GitHub. The link's in the description. You don't need to memorize it all at once. Use it as a reference whenever a command, comparison, loop, action, or object structure is unfamiliar. And pause the video if you need to. Each programming lesson follows a simple design. We introduce one concept, show the pseudocode pattern, run a small example, explain what changed in memory and behavior, and then connect the idea to real programming. That structure repeats so the lessons feel predictable. When you watch a code example, don't try to memorize every word. First, ask, what's the program trying to do? Second, watch what values appear in memory. Third, follow the behavior panel to understand the result. The goal is understanding, not speed. Here's the entire system in one tiny example. The code creates a name, shows a welcome message, changes the name, and shows the message again. Watch the code window, memory, and behavior panels work together. Now you know how to read the lesson interface. In the next lesson, we will begin the actual programming content by introducing pseudocode itself and the basic commands we will use throughout the series. And for those who are curious about the training software we're using, this was a software suite I developed myself to teach these courses. I call it Screenplay. I actually write the visuals for each tutorial as code, so they'll play all the sound cues, music, effects, and animations for the presentation as you see them. It makes creating the content much more efficient with minimal need for editing later. No mistakes, no backspacing, and we stick to the design without wandering. Thanks for watching. Continue to the next lesson when you're ready to start learning pseudocode.